Greetings everybody, this is Henri from AXBlue Support. Welcome to this new series of hands-on video. Today we will see together how to integrate an OEM INS in a vehicle. The first one will be about the unboxing experience. The second one will be about configuring in a workshop environment the unit here on this bench table. And the third part will be about the vehicle integration. I will use a mock-up AUV. In this part, we'll also have Core from RTS to give us some user perspectives about his experience integrating our OEM solution in his vehicle. The fourth video will be some tips and tricks, small details and advanced usage that I could not give you through the first three videos. This INS OEM compact range is based on AXBlue Fog technology. This is a robust and maintenance-free technology, and that will provide you up to very high performance. We'll see that through the OEM range we'd like to introduce you today. The OEM range is made of four kinds of unit. The first kind of unit is the Octans Nano OEM. The Octans Nano OEM is an IHRS only, so it's a gyro compass only unit. It will provide you up to 0.5 degree accurate heading. The second of this family is the FINS Compact C3. It comes in the same form factor, but have the inertial positioning capability. It will have up to 0.1 degree accurate heading, and when coupled with a DVL, up to 0.04% of the travel distance in terms of positioning accuracy. The third one of this family is the FINS Compact C5. You will see that it has a 154 millimeter diameter, so typically you can integrate it in an AUV portion. It has up to 0.07 degree accurate heading, and when coupled with a DVL, up to 0.02% of the travel distance. The last one, the FINS C7, is our state-of-the-art INS. It's based on the 120 millimeters fog diameter. It has up to 0.01 degree accurate heading, and when coupled with a DVL, will give you up to 0.01% of the travel distance in positioning accuracy. When not coupled to a DVL, so in pure inertial condition, it will reach about 0.6 nautical miles per hour of drift, better than 0.6 nautical mile per hour drift. So those four OEM solutions we provide you, they will be able to integrate into many kinds of vehicles. They are traditionally used into AUV designs. AUV stands for autonomous underwater vehicles, or into ROVs, stands for remotely operated vehicle, but you could consider using them in many kinds of vehicles. For example, the Octans Nano OEM could be traditionally used to stabilize a side scan sonar or different kind of equipment that needs a better heading roll pitch accuracy than their usually embedded solutions. So I will proceed with the unpacking of the FINS Compact C3. This is the one I choose to show you for the rest of the show. The unpacking will consist of four parts. The first part, we will see the IMU subassembly. The second part, we will see the electronics subassembly. The third part, we'll see about cable works and connectors. And in the last part, we'll see the paper trail and documentation, because it's quite important to remind about them. Before I proceed, I'd like to remind you about ESD, electrostatic discharges. Those units, being OEM units, they will come naked. They will have electronics apparent, and should you be not careful while handling them, you could damage the electronics. Traditionally, in your workshop, you have an EPA environment. Should you not have to, I invite you to do like I did today for the purpose of this demonstration, to use an ESD mat, an ESD bracelet that links you to the ground of the power supply, if you can wear an ESD jacket. So we'll proceed with the unboxing. You will see that it comes in the now traditional AX Blue cardboard box. In this box, there's a lot of empty space, but we have the first box, which is the IMU subassembly. So to know which smaller box contains what, you will have a small sticker that tells you about what is inside. So when opening it, you will see that you have a kind of cradle. This cradle is used for transportations, not to damage the unit during transport. Removing the unit of the cradle, you need to be careful and look carefully to see the metallic part of the IMU subassembly. So I take it with my hand, I remove the box. So now I put my ESD bracelet. You can see that it comes in an ESD protective bag that is sealed at the time of the factory. So handling this unit, like I said, you need to take it using the metallic part. So let's look at this IMU subassembly. It has a bunch of different features. The most noticeable one is where you need to handle the unit. When manipulating it, you will use this metallic part. Actually, this metallic part contains our fiber optic gyrometers, 3 of them together with accelerometers. So this is the core of the sensing part. Here we can see a bunch of apparent optical fibers. So that's why I say it's very important never to touch this area. Once integrated in your vehicle, this will not be a problem anymore. At last, we have the power distribution boards and apparent connectors. We'll see in the second series of video how to fit those connectors to the electronic subassembly. Under the unit, you can see holes to fix the unit on your vehicle and holes for alignment pins. At last, I'd like to show you this cool feature. We place here a small sticker that gives you the sensing axis of the unit. So here we have AX1, here we have AX2, and here we have AX3. We will see through the configuration part of this video how to configure them and how to visually know properly integrated the unit in my vehicle. So now I will proceed with the unpacking of the electronic subassembly. So this is the second box of the delivery. So in this box, I will also have access to smaller accessories and cable work. We'll review them later. USB sticks and a paper tile. And we see that we have, in a very similar cradle, the electronic subassembly. So I take it off the box. And again, I put my ESD protective bracelet. So likewise, this is sealed at the time of the factory. It is much more practical to handle this one. I just have to make sure, again, I touch the metallic parts. And here it is, the electronic subassembly. Before I review it, I'd like to show you about this sticker here. This sticker gives us likewise a small pictogram, but also part numbers and serial numbers information. This serial number is very important because at the time of the factory, this IMU subassembly is associated with this electronic subassembly. It means, for example, while you plan to integrate a fleet of vehicles, you cannot mix and match an IMU subassembly with an electronic subassembly. So further details, we see here the internal connectors. There is 3 of them. That's the one that will be linked to the IMU subassembly. And here we have the outside connectors, which are for serial data distribution. power data distribution, and under here, an Ethernet RJ45 socket. What is very nice about this electronic subassembly is that we give you those boards assembled together, fitted together with those metallic parts. Those metallic parts are made for heat dissipation, but not only, so that you can fix this portion in your vehicle using those 4 screw holes, or to fix it vertically like this with those 4 screw holes. Last thing it's important to say about this portion is that all the processings are done inside the electronic subassembly, meaning together, those 2 units together integrated in your vehicle, we'll see later, all the data will be processed into them. So about the cable work, let me detail you the 3 cables we get in the scope of delivery. The first one will be a test or lab power cable. So this lab power cable comes with the connector that will fit here and banana plugs. I encourage you to have your own power supply ready. Here I will use this one later on for the show. The second set of cable in the scope of delivery are what we call the internal cables. It will come in the form of 3 cables. The first one is a ribbon cable. It's the data cable for data transmission from the sensing part to the computing part. And those 2 smaller cables, they are for power distribution. Basically, we'll take the 24 volt in, send it here to this board for powering the IMU subassembly, and from the IMU subassembly, resend some power distribution to the lower boards. You will see that in the documentation, we provide you details about all those cables, but we made them so you cannot confuse them. So each of them can be plugged only one place on the unit. The last part of the cable work is those tiny connectors. So you can build your own cable in the workshop or through your vehicle integration. We will see later how to fit them and with the proper tooling. At last, the paper trail you can see here. So like I said just before, with all the important informations about handling ESD and unpacking the FINS Compact C3 unit. I encourage you to always read them when you start to open a pack of them. Together with the documentation, I will get a tiny USB stick that will give me access to all the user documentation. This user documentation will provide you with a lot of details on how to configure and how to use the FINS Compact C3, but not only. It will also give you access to the full control command you could use to communicate with the unit. For the purpose of this show, I choose to make 2 case studies and to use one for the rest of the show. Basically, when integrating this kit into a vehicle, I have 2 choices of design. The first choice of design would be what I call the standalone integration. Since all the processings are done inside the unit will become the heart of my vehicle design and deal with data communication from external sensors to internal sensors. The second case study I could use could be to use what I call the intelligent integration. For example, in the case your vehicle has already intelligence capability or control command capability, or should you desire to set up your own user interface for your vehicle design. Then this kit would become part of a sensor like the other sensors are on board your vehicle, and you would control it through control command. At last, something I'd like to explain about this kit is that it can interface to a great deal of sensors. It will be able to interface to up to 14 different kind of sensors. All those sensors are basically 3 different families of sensors. There is the positioning sensor, so we have, for example, GNSS or USBL or LBL for positioning underwater. We'll have the speed sensors. Traditionally, for surface or underwater vehicles, we would use DVLs, for example. And one very important, considering an OEM integration, is the timing sensors for time stamping and for data time synchronization. All those sensors will be configurable through up to 7 inputs and outputs over Ethernet and up to 5 input or output serially. To wrap up this session, I'd like to say again the important things we just reviewed. You will see, and you've seen, that this kit is delivered with everything, so it's made easy for you to assemble. As a reminder, all processings are done inside the unit, so you can have 2 case study of integration. This product, when we designed it, we choose to make it what we call standalone OEM. So you could use it either as a standalone sensor. Every feature is accessible through its user interface. We'll see that in the second part of the video. Or you could use it in this intelligent integration as another sensor of your design. And to finish, of course, great many vehicles that you could interface with. We will see the case study of an AUV integration, but you could put those units or design those units to be integrated to as many vehicles as you can imagine, as long as those vehicles need the most performant accurate positioning or the most performant accurate heading accuracy. Thanks for watching this show. See you in the next hands-on video for the lab configuration.